Hi there, and hi. This is another video of me solving a numerical problem. So today we have text certification. So given an array of string words in a max width of max width, right? Format the text such that each line had exactly the max width and is fully left and right justified. So fully justified. You should pack the words in a grid approach. That is, pack as many words as you can in each line. Add extra space when necessary so that each line has exactly the max width characters. Extra way between words should be distributed as evenly as possible. If the number of space on the line are not divided evenly between the word, empty slot on the left will be assigned more space than the slot on the right. Okay. So this means that if we have like a word like this, right? So this is 4, 8 ISD is 3, right? So 4 plus 3 plus 2, right, is 9, right? The 9 word, and our max width is 16, right? Because each line must have the length of max width, right? So we have how many? 16 minus 9 is 7, right? Is 7, and 7 is not divisible by 3 by 2, right? So which means that the left spot here might have 4 space, while the right spot here we have 3 space, right? Right. So you say here the empty slot the slot on the left will be assigned more space than the slot on the right, right? If the remaining space are not divide, couldn't be divided evenly between the words. Right? So that is what they meant. So we have a few requirements here. The first thing is that each line must have exactly 16, right? Max width, the length of max width, right? And then the space must be divided evenly between the word and the line, and then if the remaining space right couldn't be divided evenly between the word, then we must give the left more space than the one on the right. And the third rule is the next rule is that um, each word should have at least one space, right? For the word to be separated like as a line, then each word, right? If we have more than one word on the line, then it means that there would be at least one space between the word. Okay, a word is defined as a character sequence consisting of non-space characters only. Each word length is guaranteed to be greater than 0, okay, and not exceeding the max width. Right, so this is an HK that we don't have to worry about, right? Let's say if the max width is 16, then we won't have a word of like 17 characters, right? If it is 17 characters, then we cannot fit it on one line. The input word will contain at least one word, okay? And yeah, that's pretty straightforward, right? So if we look at the first slide here, right? So we're gonna try, right? The first task is to um, figure out how many words we're gonna have for one line, right? Before we even like try to distribute the space, just don't think about that now. So how do we know how many words we can fit on, on one line? So we need to account for the space, right? For the minimum number of space, because we know that if there's two words, then there must be at least one space between them, right? To make them like two words. So for example, we look at this. right? Which is length of 4. It is the first word, so we don't have to worry about the space. And then it's still smaller than 16, right? So we look at is. Okay, this is the second word, right? So we add 2, right? But we also have to account for the space between this and is, right? So we add 3 because it is the minimum number of space we need, right? 1. So 7 is still smaller than 15. So look at n, right? Two length of 2, but also need to account for the space. So 3 for the minimum space. So 3. Okay, the next one is so 7 plus 3 is 10, right? It's still smaller than 16, right? So we look at the next word, example. Example have 1, 2, 3, 4, 5, 6, 7. It is the length of 7, right? So we need to account for the space, but it is not the first word, so we plus 8, right? So now we have 18. 18 is richer than 16, so we stop, right? So that is why we only have these 3 on the first line, right? And we continue on, right? So example is 7. It is the first word, right? This is the start of the new line. The first word, right? So only 7, right? The second word is length of 2. So we need to account for the space, so plus 3. The next one is 4. Account for the space is 5, right? So we have 15 now, right? It's smaller than 16. And if we add the next word, right, it's going to be over greater than 16. So our next line stop here, right? And of course, the last word is on the last line. Okay, so that is our task. Our first task is just to try to get the words, try to figure out what words, so how many words are on a line, like what words should will we have on each line, right? That is our first task. Before we even try to distribute the space evenly between them, we just want to know and store um, the words for a line, right? For each and every single line. And we need to account for the minimum number of space, right? Between the word. If we have more than one word, which is like the minimum space is one, right? Okay. So we're gonna have like a line here, right? We're gonna like pretend at the end, like okay. So our first step is to iterate the word, the words, the line, with plus plus. Okay. So we need a line, right? We will represent a line at a string, right? Instead of an array here. So we can do y I is less than word length. So we can keep adding, right? We can keep adding the word to the line until the line length exceeding the max width, right? Okay. So we have to get the next word, right? So the next word will just be words of I, right? If it is the first word, right? But if it is not the first word, then we want to return the word with a space in the front, right? With a space in the front, right? So if it is the second word, we would do this. If it is the first word, we only want the words of I, right? Okay. So we can do something like so line at length, right? So if there's line at length, which means if there's a length on line, which means it's not a first word, right? Then we will have to return a word with a space, words of I, right? With a space. Otherwise, we have to return the word of I, right? So this is the only difference. So if the line has any length, which means there already be a character there, so we return a space in front of the word, right? Otherwise, we just return the word because it is the first word. So the first step is to adding you can say adding words alive or just like figuring out the word for each law. Okay, right. So now we have our next word, right? We need to calculating our next width. So what is the width of our line after we add this word? Would be the line, the length, right? Plus the next word, that length. Okay. So if the next width is greater than the next width, so we haven't added the word to the line yet, right? We will add it here after the next word, right? But before that, we need to check, right? If the next, if we add this length, if the next width, right, after we add the word, the new word is greater than the max width, then we need to break, right? And then determine I by 2. So after we add the word, right, we need to also incrementing the I. Or we can like increment the I here. I think that also works, right? And in that case, we only have to do I minus minus here, right? So the I minus minus here, that's like we are looking at the example, right? Which is the last word on the last line, right? Which is it's just too long to fit in the line. So we just say minus minus to go back to the example, right? So on the next slide, okay? And yeah, that's pretty much it. Let's me first of all the lines to see what we have. Okay, it's not printing anything. Oh yes, because I have to push right the line uh into the lines array, right? Maybe something is not um quite right here. Line plus equal increment I, push the new line in. Okay, we look at the next word, of course. Runtime error. Okay, so I think it's just like glitch here. I just refresh and it's just work. So yes, we have our next width, right? We increment the word every time, right? So if the next width is greater than the max width, right, we just increment I, right, to try the current word again on the next slide, right? So after that, after we finish, right, this is what we have, right? We have an array of the word, right, for each line, right? The first line, like this is n. The second line example of text, right? We'd have put the minimum number of space here. The next one is justification, right? Okay, so that is our first task that is done. So the next thing that we have to do is to uh, distribute display uh, evenly between word, right, in each line. So to do that, how can we do this? So if you look at um, what we currently have, right, this is n. So this has 4 plus 2 plus 2, right? which is 6 and 8, length of 8, right? So so the max width is 16. So the remaining space we have is 8, right? So we can distribute the remaining space, right, evenly between the word here, right? And remember that the last line, it has to be left justified, right? Which means we just leave it as it is and add the space needed to make the line become length of 16, right? Right. Or if the word length is or if there's only one word, right? So the last line gonna be left justified, right? So we don't do anything to it. We just add the remaining space. We don't distribute it. We don't distribute the space in between the word. We just add the space here to make the total length of the line become a max width, right? But if you look at the second line here, right? If there's only one word, then we just add the space again. Right? All right. So let's do this. So um yeah. So remember the total length is 16. It's 8. Right. So we can iterate through the line that we just built, the line right, that we just built, lines of length and plus plus. Right. So the first case is we need to check if it is the last line or not, right? Last line is equal to if I equal to lines of length on the front. If it is the last line, then it's pretty simple, right? We just like modify the line. So remember our line here is a string, right? It's already a string. So you just have to do lines of I equal lines of I plus the space, right? The remaining space. So how many space? It is will be the max width, right? Minus the lines of I uh, minus the length of the current line. Right. So if it is uh, the last line, right, then we don't care about um, the space in between the word, right? We're gonna just give it a default space of 1, which we already taken care of when we're building out our lines array, right? We already account for the space. We know that the space between each one needs to be at least 1, right? So let's say this already built out, right? So the remaining space here will just be the remaining, right, of the max width, right? The difference of the max width minus uh, the current length of the line. So saw is 5, right? And the space is 1 and the B is 2, right? So the remaining space is 8, right? Um, okay, so that is the first space. So the second case is when we have the total word, right? Is equal to 1. So what do I mean by the total words? So the total word is like this, right? So if we split everything by the space, then we can get an array of words, right? We can do words equal to lines of I, right? A split on the space. So if we split on the space, then the word gonna be the words array, right? And we can have a variable called total words, right? Equal to words at length. Okay. So if the total number of words that we have is only 1, right? And it's also a special case. We can just like add the space, the remaining space here, right? The life of I equal to life of I plus the space, right? For 50, a max width minus. So what are we minusing here? We cannot minus the length of the line, right? We had to minus the um total characters that we have. Uh, Or actually, I think we can combine them, right? We can combine them, I believe. Yes, I think we can combine the two case, right? Because the total characters is the length of every single characters like in the line combined without a space, right? However, if the line only have one word, which means there will not be any space, right? Because we already account with here, right? If it's the first word, then we don't have any space. And we can see that the justification here don't have any space in the front. So yes, my bad there. I think we can combine them easily. So if the or the total words equal to one, then we just like add the remaining space right to them, right? Else, so else mean it is not the last line, and the total we have more than one words, right? So which mean that we need to distribute the space evenly between the among the words. Okay, so how can we do that? We have to calculate the remaining space, right, which is the max width, right, minus the total uh, characters. So how can we calculate the total characters? The total characters will be the total length of the characters, right? The length of the character will be the length of the line without a space, right? So if we split um, the string, we're gonna have something like this, right? This comma is, right? Comma n, right? So we're just gonna have to join them, right? And look at the length. So equal to the words, right, of join and then not length. Okay. And then we just have to iterate through the words array, right? We iterate through the words array, right? This array right here, and just keep adding the space to each spot, right? Until we're running out of space. So we always start on the left first, right? And the next word, we have the space on the right here, right? And we don't want to we want to exclude the last one, right? You want to exclude the last one because we only need the space in between the word, right? So we exclude the last one. Okay. And yeah, we start on the left and on the right, left and right. So in this case, when we will have a space, if the space cannot be divided evenly, the left will always have more space than on the right, right? We can do like y space is greater than 0, right? We can do words of j beside 0 here, right? Plus equal to space, right? And you can determine the space, the cap of the space, and we have to update j, right? So j equal to j plus 1, right? And we need to mod by uh, the words of length, right? So that it will never go out bound. And remember, we want to exclude the last word, so we need to mod by the length minus 1 here, right? So if the length is 3, right, it's gonna go like from 0, right? Uh, so the length is 3, so minus 1 is 2, right? So we're gonna mod by 2, right? So 0 mod 2 is 2, is 0, right? 1 mod 2 is 1, right? And 2 mod 2, right, is 0 here, so on and so forth, right? And then after we add right, after we add the necessary space here, right, we add the space here. So after we finish adding the space, we can just join the lines again, right? The lines is at I is equal to the line equal to the words, right? That's join. We can join by an empty string here because we already have uh the space after each word, right? So we can just join them, and I think that's pretty much it. And it worked. Thank you for watching.